In this mathematical video, we solve an exponential equations. The exponential equation is one in which a variable in power form. So here x is power form. So our equation is that 1 power x is equal to 3. Now we start the solutions. Firstly, we take natural logarithms or ln on both sides. So if we take a natural logarithm or ln on both sides, so ln 1 power x is equal to ln 3. So on the second step, we know that the power in the natural log comes on the start. So this x comes on the starting. So this our next step is that x natural log of ln 1 is equal to ln 3. Now on the next step, this ln 1 comes on the right side, it on the divide side. So our next step is ln 3 divided by ln 1, ln 3 divided by ln 1. Now we know that ln 1 values is 0, so x is equal to ln 3 divided by 0. So this is not a possible. So here x has no solution, no real solution. So x is equal to no real solution. So for this we solve out that is equal to cos of theta plus iota sine of theta. So if we replace theta is equal to 0, so we have an answer is that e power iota dot 0 is equal to cos of 0 plus iota sine of 0. Now we know that the sine 0 is equal to 0 and cos 0 is equal to 1, and when we multiply iota with 0, so our answer is 0. So e power 0 on the left side, and here cos of 0 is equal to 1 plus, and sine 0 is 0, so 0 multiplied by with iota is 0. Now we know that any number that power is 0 is equal to 1, so 1 is equal to 1, so condition is satisfied. Now we replace theta is equal to 1, theta is equal to 2. When we replace that, then this condition is also hold. Now we put theta is equal to 2k pi. Theta is equal to 2k pi. Is equal to 2k pi. Because 2 pi is the period and where k start from 1, 2, 3 and so on. So if we replace that, so on the above equation, so our equation becomes that e power iota and 2k pi is equal to cos of 2k pi plus iota sine 2k pi sine 2k pi. Now we know that cos 2 pi is also is equal to 1. So here e power iota 2k pi is equal to 1 and sine 2 pi is equal to 0. So sine 2k pi is also 0. So 1 plus 0. So e की power iota 2k pi is equal to 1 is equal to 1. So we replace in our question 1 is equal to e power iota 2k pi e whole power 2k pi iota 2k pi iota. This one is equal to e power iota 2k pi and because this is equal to 1 and whole power x as it is, and here e power 2k pi x is equal to 3 is equal to 3. Now we take ln on both sides. So if we take ln on both sides, so our expression becomes that e power we write is as 2k pi iota and whole power x is equal to ln 3. Now we know that again this x power when it multiplied by with 2k pi iota, so it becomes ln e whole power 2k pi iota x is equal to ln 3. So on the next step we know that these are terms that in power form come on the start. So this becomes 2 dot k dot pi dot iota dot x and natural log of ln e is equal to ln 3. Now on the next step we know that this ln is cut out. This ln is cut out with this e. So we cut out. So we have an answer is that 2k pi iota x is equal to ln 3. 2k pi iota x is equal to ln the divide side, and on the left side simply x is remain. So x is equal to ln 3 divided by 2k pi and iota. We can write it as. Now on the below section there is iota, so we rationalize to remove that this iota on the below section. So we multiply iota on the upper side and on the below side is also with iota. Now we know that x is equal to this iota and natural log of 3 becomes iota ln 3, and here 2k pi and this iota and iota together when multiply iota square, and we know that iota square values comes out minus 1. Iota squares, so this iota we multiply by with this iota, so it becomes iota square. Now we know that iota square values is minus 1. So when we remove this iota square, so we have an answer is that x is equal to, we write that ln 3 iota and divided by 2k pi and this iota square as minus 1. So is equal to is equal to this minus 1 when multiply ln 3 iota over minus 2k pi. This minus we can also write on the upper side, so x becomes that minus ln 3 iota divided by 2k pi. So this is our complex related solutions, that x is equal to minus ln iota over 2k pi. So I hope you enjoyed that how to solve this type of the exponential equation. So if you like that, subscribe my YouTube channel X Math 786. Meet in the next videos. Thank you.